Okay, welcome back. It's Mrs. Stipe again, and before we start talking about today's topic, the vertex form of a parabola, I thought I'd do a quick review of everything we know so far about parabolas. And so on the screen you'll see the standard form of a quadratic, y equals ax squared plus bx plus c. And from this form we can tell two really important things. One is that a tells us the direction of opening. So when a is greater than 0, the parabola opens up, and when a is less than 0, the parabola opens down. Okay. The other thing we can see is that 0 comma c will be the y-intercept. Okay. So once we have the standard form of a parabola, we're interested in finding the x-intercepts. And so the x-intercepts, where the graph crosses the x-axis, also sometimes called the solutions to the quadratic, are found three ways. Easiest way is to factor, but we can also use the quadratic formula, and we can also complete the square. But always the fastest is to factor. All right? When we have the x-intercepts, we can find the vertex of the parabola by, first of all, we can find the midpoint of the x-intercepts. And what that gives us is the x value of the vertex. And remember, the vertex is that maximum or minimum point where the parabola changes direction. Second way to find the vertex, and it's a little bit easier, is to just simply find the value of negative b over 2a. With both of these, though, remember the vertex is an ordered pair, and so we can't just stop with the x value. We have to find the y value by plugging in. There's no easy way to do it. You plug in the x into the original equation, and what is how you evaluate that x, what you get is your y value. Okay, so in class today we learned about this new form of a parabola, and that's called the vertex form. So let's get right to the vertex form of a parabola. And it's not that complicated, right? It's just really truly a transformation. So you're realizing how important transformations are in this class. And when we get to vertex form of a parabola, it's simply a transformation of the basic function y equals x squared. So if I gave you y equals x squared, the basic function, and told you to graph y equals 2x minus 3 parentheses squared plus 4, here's what you would be thinking. You'd say, oh, I know that this parabola has been moved 3 to the right and 4 up. The 2 here, we remember, is a scale change. It has the effect of making the y's twice as big, but the transformation is really what we're talking about. And so if this is the graph of x squared, then the transformed graph would be 3 to the right, 4 up, 2, 3, 4. Same direction of opening. It would be a little bit narrower because of the 2 there, but the idea is that when you do a transformation on the basic graph of y equals x squared, what you've done is you've put the parabola in vertex form. Okay? Right? So let's go ahead and generalize and say that when we have a parabola y equals a x minus h parentheses squared plus k, that the vertex will always be the ordered pair h comma k. Okay? It's as easy as that. So let's go ahead and look at an example of one. If I give you y equals, and let's for fun put a negative in front, and say I have x plus 5 parentheses squared minus 8, you would know these three things about the parabola. You would know that the vertex is 5 to the left and 8 down, right? So this is 5, negative 8, right? And because of the negative in front of it, the parabola is going to face down. All right, so vertex form of a parabola is very, very convenient, so we're going to go ahead, talk really quickly about how we change a parabola in standard form to vertex form. And the great thing about this is that you've done this before, and it's just a form of completing the square with just a slight difference on it. So if you're good at completing the square, you're going to be really good at changing this to vertex form. So here's my standard form of a parabola, and I want to change it to vertex form. So step one is to go ahead and, like we did before, take the first two terms and put a plus blank, and that's going to be the completing the square part. And then here's the big difference. This plus 3 does not move to the other side. We just move it a little bit further to the right. All right, so once we do that, we're going to go ahead and ask ourselves what number it is that completes the square with 8, and I think that you guys are really good at this by now. Half of 8 squared is 16. Now this is also a different part. Instead of adding 16 to both sides, what we do is we turn around and subtract 16 right away. So you would agree that if I add 16 and then subtract 16, that's the equivalent of adding nothing. All right, so I haven't done anything to change this side of the equation. The value of it, I've just changed how it looks. All right, so the reason we do this is that then we can write this as the binomial x minus 4 squared minus 13. Put those two together. So this is the vertex form of the parabola, and the vertex is at 4, negative 13. Okay, so hopefully that cleared some things up for you. See you in class. Thanks for watching.